we have Runcy Oommen. He'll be speaking about practical steps for AWS Security Posture improvement. Runcy is...
Test. Okay. All right. Good afternoon, Kochi. Okay. Still awake? Yeah. Okay, good. So my name is Runcy, and I'm the one standing between you and the goodies. Right? So this is the last session, doing it for the last in this track. So anyway, nevertheless, it's a pleasure to be here. I think it's my third time at the Community Day in Kochi. I've been here in 2019, 22, and yeah, this year. Okay, so let's talk about some of the important steps that you could do to improve the security posture enhancements of your AWS account, and that is what we are going to be looking at. So this is sort of like my promise to you in the next 30 minutes. We are going to be looking at a very generic cloud security introduction to set the tone, and no session on security is complete without the shared responsibility model. So I'm going to basically talk about that and then dive into the meat of my presentation, which is basically the specific AWS services that we are going to be looking at for hardening, okay, or for improved security enhancements. So a little bit about me. On the professional front, I've been in the industry as for multiple number of years. Primarily in the security domain, special interest in serverless. I believe in a multi-hybrid cloud future. On the community front, I'm the organizer for the GDG Cloud. I was the co-organizer for AWS User Group, and I've participated and won in multiple hackathons in anyway. Okay, so that's about me. So let's define what cloud security is, and all of you can read, and I'm going to repeat what is there on the slide, but look at the ones which are highlighted, right? What does cloud security mean? And it's basically a sort of like a 10,000 feet overview of policies, technologies, applications, and controls, right? Which are basically used to protect your IP, data, applications, services, and infrastructure. That's sort of like a very narrowed down definition of what cloud security or any software security per se is. And I've taken this definition right out of Wikipedia, right? But let's keep this a little more interesting. You know, I know we are in the last session, and let's play a game of Pictionary along the way. So I hope all of you know what Pictionary is, right? You are supposed to come draw something, but we don't have a board here. So what I've done is we're going to play a Pictionary game of AWS services, and over the next of the course of the presentation, there's going to be some slides where some AWS services might pop up, and you are supposed, whoever shouts up the first, there are some interesting giveaways, okay? It's a gaming mouse, okay? So there are like multiple gaming mouse that's going to come up, and I'm going to give it. But I believe the organizers would have seen all these things, so you are not supposed to participate. Okay? It's only for the attendees, because you would have got a edge with seeing my presentation ahead, right? Okay. So, excited? Okay, so let's start. So, to set the context, you know, the IT infrastructure sort of like has undergone a paradigm shift, and more so in the last 2 decades. And what exactly does that mean, right? Because when I joined the industry, right, this is the sort of network architecture diagram that was given to me by the person in charge of the IT network and security, right? The big bad world of internet sitting behind a firewall, which is letting only the good traffic go through and blocking everything, right? But this is the new way. CAS, SPAS, DAS, FAS, whatever as, right? It's all up in the cloud, right? The enterprise is still there. So this has changed. The way we work, the way we access our applications, it's sort of like changed over how it is used to be, right? There are no more VMs and all those close network stuff that used to be residing within the application, within the enterprise. So if that's the case, you should be also thinking security a little differently. we cannot have the same set of controls or ACLs or network rules to basically have the same set of workloads, because the workloads have evolved, right? So your security mindset should also be a little different, right? But to understand that, you need to understand the important facets of the cloud, because cloud is everywhere. Gone are the days, when I joined the industry, I think I started my career in Infosys, we used to have internet access from 5 p.m. to 6 p.m. That's it. Now, do you care? If I go, the Gen Z kids, right, if you go talk to them, right, they'll have their hotspot on and then they'll access an AWS and GCP or whatever, you can have it accessed anywhere. So the cloud is become ubiquitous. It's scalable. At a push of a button, like we've had multiple sessions with respect to Kubernetes and serverless and everything. At a push of a button, you can have unlimited load, right? And it is deeply integrated into your office network or your home network. You can no longer segregate your cloud or your private workload, right? Because it is deeply integrated within your system or whatever, right? So with that, let's look at the first Pictionary. Whoever is shouting up, so I'm gonna look up who's gonna give the answer. Who said that? Yeah, come over here. So this is a cool gaming mouse, the first of the giveaway, right? So I'll throw it, catch it, okay? Okay, so there are more. There are 3 more that's coming up. So let's keep the momentum. So with that, let's look at the shared responsibility model. And I want to touch this very briefly. All of you must be very familiar. But the shared responsibility model is basically a two-way street. It's not that you secure the security of your application is not solely AWS responsibility or the infrastructure provider's responsibility, but also your responsibility. That is security in the cloud and security of the cloud. What does it mean? Because security of the cloud is your perimeter of the data center to make sure that the Cat6 cabling is being used inside the data center to prevent eavesdropping. That is AWS responsibility. But if you have your data or your application in the cloud, and to make sure that unnecessary ports are not open, you are using the right certificate, you are having the right key strength, that is your responsibility, right? So it's sort of like a shared responsibility where you and the infrastructure provider takes equal responsibility in protecting the data, applications, and whatever thing that is running there, okay? So with that context set, let's start the hardening process. And this is sort of like an analogy. The castle that you see here, it's in a pretty bad shape. It's analogous to your AWS account right now, right? Which has got the default config. Now let's start hardening each of the important services that I have picked up. So posture improvement number 1. Ensure you have the below checklist while using EBS, that is the elastic block storage. So what are the checklist, right? Your EBS volume is encrypted, the public access to snapshot is disabled, and your unused EBS volumes are removed. So let's look at each of them, right? So now, for a EBS volume, encryption at rest is by default provided. That is, if you have your EC2 instances, you can attach your EBS and your encryption is provided. But what it actually does is it reduces the likelihood that if your EBS is compromised, if there is an encryption that is broken, right, your EBS still remains encrypted and you can nullify the impact, right? By default, the encryption, as you said, is not encrypted. It doesn't have any KMS or any of that associated, right? Simply enable it by encrypting this volume. By making sure your EBS will be encrypted by whatever key you want, right? So this way, your volume that's attached to an EC2 instances will be encrypted, and even if your account gets compromised or even if it gets copied away, the data still remains there. Because even if you delete or if you're not using an EBS, the data is still there. So the chance of a compromise would still be there, but if it's encrypted, it is nullified. The next one, you can protect your data by disabling the public mode of EBS snapshot, right? So you can take a snapshot of an EBS, but make sure that your snapshot is not publicly accessible. And you can do that by making sure that it is only private, which is the most secure way of doing it. Never expose it to a public, which could probably lead to cross-account proliferation and all of that, right? So this is another way that you can accidentally prevent the accidental sharing of your snapshot. The other one is like whenever you terminate an EC2 instance, make sure your unattached EBS volumes are automatically terminated or automatically deleted, right? And this would prevent the unauthorized access and sensitive data leak, right? So if you go through and filter all your EBS volumes, see, these are the ones which are in the available state. That means it is not being used. All these are consuming money, and all of them are basically security risk, because none of them are attached to any running EC2 instances, because just an example, it's created in a very old thing, right? This is from my example account. And make sure that you don't have anything which is there in an available state. Okay, so with that, the next picture. And I'm gonna stand to the corner so that I can get a clear view. Who's that EKS? Okay, come. Yeah, AWS Elastic Kubernetes Service. Can you catch? Okay, good. All right, let's move on. Posture improvement number 2. Ensure the below steps for the safe usage of Elastic Beanstalk. So we talked about the EBS, now let's talk about the Beanstalk, right? You have the platform update is configured, that is one of an important one, and persistent logs are set up for the Elastic Beanstalk. How do we do that, right? Or what does it actually provide? By enabling the platform update, what it does is it helps you get the fixes, the vulnerability patches, and helps you through a scheduled maintenance window. And more importantly, your application actually remains in service even through all of this, right? So a simple checkbox, that is, you enable for the Elastic Beanstalk, make sure that the platform update is activated for whatever time that you select, and you can select whether you want the patch update or a minor and patch release and all of that. This is the most easiest and the simplest way to make sure that the Beanstalk is up to date. Now, persistent log setup, right? What does it actually do? Because by enabling the persistent log setup, you can automatically stream the logs to CloudWatch. And this way, you helps to monitor and archive your Beanstalk application. So this is not a default configuration. You have to have it enabled in your Beanstalk. That is, you have to activate your log streaming, and you can select your retention cycle and keep the logs after terminating the environment. So this way, even if your Beanstalk is terminated, you still have an audit trail of what all went through for your audit purposes, right? So this is very simple two-step process to ensure your Beanstalk is up to date, with making sure your audit trail and also making sure it's up to date. Okay, next step, AMIs. So this is a very simple one. If you are using a managed AMI, not the ones which you have created, make sure that it is not older than 90 days. Because 90 days is a lot of time to make sure that it is obsolete, you are not getting the right updates and everything. So just audit your AMIs frequently, and this is an example. So these are the creation dates. So all of these should not be used to create any instances or EC2 instances, because this is deprived of any OS patches, updates, and could have severity concerns and compliance issues. So this is a very simple check to make sure that your AMIs are up to date. Fourth one, with respect to the AWS batch, and again, you make sure that whenever you use AWS batch, it sends important information to the CloudWatch. And why that is important is because it helps you to view the logs from all your jobs from one convenient location. because you don't have to run across different accounts and everything to make sure that, and even different regions. If you have your logs configured for AWS Patch, everything comes up to one link. And this is not a default setting. You have to have it enabled, because this will play a crucial information for what is actually happening for every AWS group. Because debugging AWS batch is a nightmare. I don't know if you have worked with it, but you wouldn't come to know as to what is actually happening. But if you have logs enabled, it becomes very easy to see what is happening, right? Again, this is not a default setting. You will have to enable it. Okay, so with that, the third one, let's see who can get this. I think it's a simple one. No? Huh? No? No? Oh, I'm so taking that gaming back. Gaming was back home. Come on, come on. Just look at it. Just look at the picture. Cloud is right. Huh? No. Oh, come on. No. No, not glue. Cloud is right. I give you that. Cloud? No. Come on, guys. No Windows users? No. Ah, cloud directory. Yeah, who said that? That. Yeah. Can you catch? Oh, am I sorry? Okay. Let's go. I think this is the last one. Yeah, this is an important one for AWS Lambda. I wanted to go a little more detailed with AWS Lambda, so I've gone the full example. Because if you have incorrect validations, because it could lead to elevated privilege, and this is sort of like a more detailed one, because with the elevated privilege, you can have sub-process invocation. You could get access to the function handler, which would basically expose the whole code, and then you could even execute os.system. So let's see what exactly I mean by each of this, okay? And by default, when you provision something in a serverless, it should be within a VPC, right? And however, the VPC is a SDN fabric. It is as good as the vulnerability or any of it that can exist. So it is very easy to jailbreak this VPC, right? And that is some of the stuff that we actually have this in mind, that it's within a VPC, it's all secure, but no, that's not the case. It is only as good as how you have done your validation. If you have done an incorrect validation, it is possible to break out of the VPC, because it's a SDN fabric, right? So I've been talking about so much. Let's look at some of the code examples. So here is an example, right? Look at this program. It's a very shallowly written program. What it does is, it is a CV processing application which accepts a CV in a PDF format, and it performs text analysis, right? So here there are some files. You are expecting that it will be a PDF and all of that. But what is the assumption? Assumption is that the user who is going to be using this application would only provide a legitimate file name, right? That's an incorrect assumption by the developer of this application. But there is a weakness. That is, a file name that is embedded into a shell can directly provide access, right? For example, the one which you see down, this is a perfectly valid file name, but it's a bit crafty. What it does is some foobar, that is foobar.pdf, but I've terminated it with a semicolon, and I'm running a whole set of curl commands and ending it with a PDF. This is how an attacker would work. This is a crafty file name, right? If I upload this, what it is going to do is, in this Lambda function, it is going to send all of this data and then upload it into the attacker site. So this validation is not happening in this PDF processing application, right? So these are the incorrect assumptions that can happen. Now what would happen as a result of this? As a result of that, you could do a sub-process invocation from the execution context. So what it means is, here, assume you have jailbroken it, and you have a Python application for Lambda, and we know that the process ID is 7 or 8. So this is the process ID for a Python in Lambda, okay? It is inbuilt in AWS. It will always be 7 or 8. So what I'm doing here is, I'm doing a ps command, outputting it into process.txt. I'm opening that in a read-only format, right? And then I'm changing the process ID to 7 or 8 by using the ps3 command. And then I'm reading all of that and then closing it. So this is possible because once you have jailbroken into the Lambda function using any of the stuff, you can do any of the os.system commands, anything, do play around, get the source code, right? Even more access the function handler of the serverless function. What it actually does is, I know that it is a Lambda function which is written in Python. It's got a certain format that I can follow. Now what I can do is, I know where it is executing. The Lambda in AWS is executing under /task. So what I've done is, I've written a Lambda function. It will be the name, Lambda underscore function is the default function name for Python in AWS. And I'm putting that into temp code.txt. I can get the full code that is being run within Lambda by if there is a vulnerability. And just open that file and then return the code. See? So this is the way an attacker can affect or attack your organization if there are no incorrect, if there are no proper validations that are being set. So this is one example, right? So how do you work around this? Now this workaround is only possible in terms of a Python, and in Python there is something called as a monkey patching, right? What it does is, it is a technique to dynamically obfuscate or piece of code, right? So you change the behavior of the source of code dynamically. And how it is done, or why it is rather done, is because when you want to change the inbuilt behavior, like say for example, we looked at the os.system command, I want to obfuscate that, or I want to change the behavior of that os.system, right? I'll give you the example for it, right? And when do you do it? You do it when your time is less, or you want to roll it to the production very quickly and all of that, or there are no experienced developers who can actually write safe code, right? But you want to get it out quickly. So let's look at the monkey patching examples on how it is being done, right? So here, this is the same code. What I've done is, I've changed the system original definition of os.system with a custom one. So I've created a non-working system, right? Because attacker wouldn't know what this is. Attacker would try to write the function with os.system, but I have obfuscated it with something else. And when I create a new program or a Lambda function, I create a new safe os.system. This only the developer would know, nobody else. So I'm not directly using os.system, I'm using safe underscore system to basically do the calls, right? And this way, you are basically eliminating all the things. So here in your Python function, you are no longer using os.system. If you try to use os.system, that is the attacker, if he tries to use the os.system, it will give an error. The programmer would only use the real system over here, the safe system, right? So this is one way that you can alleviate the techniques that common attacker would use within a Lambda function. So these are some of the ways that you can actually use, and you can repeat it for any number of things. And mind you, this is only for Python, okay? For Go, C++, and all the other things, there could be other techniques. I'm not familiar with it, but there are other ways that you can use to mask your existing function. So with that, the hardening is successful. You can see that the castle is looking much better right now, right? So thank you, everybody. And the last one before I sign off, right? The last one. No, say it fully. Ah, yeah. Who said AWS Community Day Kochi? Yeah, correct. AWS Community Day Kochi. Yeah. Okay. So yeah, thank you everybody. Nice. And I don't know if there is time, but I can open for questions.
Yes, open up for questions. Anyone with any token of gratitude? Let me invite Ashwin to give a present a gift to Runcy.